talk about another simple application of integration. Let's say this is y and this is x axis, and we have the curve like this. This one y equals fx. Let's take this small point x. This base will be x plus delta x. This base is delta x, and this base is y. This base 2 will be y plus delta y. Before we go into this, I want us to look at, if you have a cylinder, the volume of this cylinder will be, this is r, this is h, pi r square height. So if you look at this one now, just keep this. Let us now say I rotate it around the x axis. It's going to be also something like this. Can you see? And let us now take this small element, y delta x. So the approximate area of this, so it's going to be to give me a shape like this. For this one, it's going to give me a shape like this, enlarged. Y. Just like I did here. So this place, this h here, is my own delta x here. You can see. It's my own delta x. Now for this small, this thing, when I rotate it, it's going to give me something close to this. It's 360. So the volume of this one, of this element, is going to be approximately pi y square. Yes. Are you seeing this? So when I have delta x, delta g over delta x to be pi y square. You see, when delta x now tends to 0, delta v over delta x will tend to dv dx. So dv dx will be equal to pi y square. So dv, so v, let me put that, v will be equal to pi y square dx. You can see for this element, but it is not just for this small one. We are going to add it for all the other small parts. You see, until it gets to this place. Therefore, the whole volume is going to be pi y square dx from x1 to x2. So let's say this one, this base is x1. It might be from anyone, it can be 0 to any point. So from x1 to x2. So this is the expression for the volume. If it is rotated around x-axis, and the expression is given in terms of x, that is y is the function of x. That is one of the calculation. That is one way of calculating the volume. The volume can be in any other form, but this is the first one. I believe for this level, I am taking 3 of it. So this is one of it. When it is rotated around the x-axis, please take note of this. Just like we had it in what's it called? In area, we can also have this rotated around the y-axis. Around the y-axis. Let's say we have it like this. And we now rotate it round like this. There is a way they will ask you the question. And it will be this one around this place. That is this side. This is the second way. This one we also, this V here, in this instance, will be x square dy. From y to y. Please take note. This is the second form. This shape can be rotated around the x, the y axis, and they will ask you about the volume generated by the curve and the y axis. We have done one here. This is between the curve where it is rotated around the x axis. Please take note of that. So we have two expressions now. Now the next one is this. When this one, the volume generated, when this is rotated around the y axis, by this shape, rotated around the y axis. Please note, the former one was this place. When it's rotated. You get it? That is the second one I just talked about. But in this instance, So in this instance, it is like this. This shape is now, you understand? It's now the one rotated around the y-axis. And how do we find the volume for this one? We take this element and this element now, you know, it is now circular. It is now circular. So we take this part as delta x. And from here, this base is x. You can see. And this base is y. You understand? Now if you look at this, let's take this strip, elemental strip like this. For this place, this place is delta x. And this place is y. The volume of this small part, if it is rotated, you know it now, it is going to be, let's talk about the length of this part. Length of this part, because it's very small, that's why you can take it like this. The length of this place is going to be 2 pi x. This place is going to be 2 pi x. That's the length. So the area of this strip, is going to be 2 pi x delta x. Please take note. This place, this area, is 2 pi x delta x. Now volume is area times height. So volume of this part, so V is going to be height, which is y, times 2 pi x delta x. So dV delta x is going to be 2 pi x y. So when delta x now really tends to 0, delta V over delta x will tend to dV dx. So you can see. So dV dx in this instance is going to be 2 pi x y. So dV is going to be 2 pi x y dx. So V will be the summation of these strips up to any extent, and that's going to give you 2 pi, sorry, this one is 2 pi, 2 pi x y dx from x1 to x2. So you can see I have given you 3 scenarios. The first one, the second one is around this place, and the third one is this shape itself forming like fan, round, and you take it by using 2 pi x. Do you understand why? But if it is just this curve up around the y axis, it will just be pi x squared dy, and you know how to do that manipulation due to the lectures we had in the past. Now let's look at examples of having this. Please take note. When I do something like this, or from all the 3 formulas, your x1 does not necessarily start from 0. It can start from any value. It will still be accurate. It can be from 2 to 3, 2 to 10. It will be accurate. Please take note, because I just realized in my drawing it could have stressed from 0, but x1 does not necessarily need to be 0. Now the question is, find the volume generated when the plane bounded by y equals to 5 cos 2x. The x-axis and ordinate at x equals 0 and x equals pi over 4 rotates about the x-axis through a complete revolution. So what they are saying is this. This is going to be something like this. So it now moves round, 360 degrees. So how do you find that? We know that it's going to be V is going to be y squared dx pi from 0 to pi over 4. You can see. So let's start. What's our y? 5 cos 2x. So our y squared will be equal to 25 cos square 2x. And you can also say it's going to be 25 over 2 into 1 plus cos 4x. Remember? So we have gotten our expression for y squared. Therefore, V is going to be pi over 4, 0. 25 pi over 2. So 1 plus cos 4x dx. So we integrate everything here. So it's going to be easier from here. So I can now say V is equal to 25 pi over 2. So x plus sine 4x over 4. From pi over 4, from 0 to pi over 4. And that's going to be 25 pi over 2. So this one is going to give me pi over 4 plus sine, 4 times pi over 4, that is, what do you call pi, sine pi over 4 minus 25 pi over 2. And what, that is 0 plus sine 0. You can see. So, this is minus, please take note. I'm subtracting this one from this. So at the end of the day, it's going to give me pi over 4 is there. Sine pi is 0. So it's going to be 25 pi over 2 into pi over 4 minus 0 minus 0. What is sine 0? 0. So at the end of the day, my answer is going to be 25 pi squared over 8. So you can see, all you need to do is just to convert this. This is where it is. Just get your y squared and your answer is okay. Now look at this. The parametric equation of a curve are x equals 3t squared and y equals 3t minus t squared. Find the volume generated when the plane figure bounded by the curve, the x-axis, and the ordinate corresponding to t equals 0 and t equals 2 rotate about the x-axis. You can see, rotate about the x-axis. They have told us the shape that rotates. Is that clear now? The shape, they have told us, bounded by the, when the plane figure bounded by the curve, the x-axis, you can see, that is between the curve and the x-axis, and the ordinates corresponding to t equals 0 and t equals 2 rotate about the x-axis. So the formula we are going to use here is also pi y squared. Yes. So that is the formula we are going to use. Now let's continue. So we know what our x is. 3t squared. So our dx is going to be 6t dt. Our y is 3t minus t squared. So y squared is going to be 9t squared plus t raised to power 4 minus 6t cubed. You can see. Therefore, v will be equal to pi 9t squared plus t raised to power 4 minus 6t cubed to 6t dt. What is the range from 0 to 2? So it's going to be, when we bring this, I can make it like a 6 pi 9t raised to power 3 plus t raised to power 5 minus 6t raised to power 4 dt. You see, this I brought this outside here. This is what. So it's going to give me 6 pi into 9t raised to power 4 over 4 plus t raised to power 6 over 6 minus 6t raised to power 5 over 5 from 0 to 2. So that's going to give me 6 pi into, so you can see 6 pi to 9t raised to power 4 over 4 plus t. So on inputting 2 and 0, I have 36, 64 over 6 minus 6 times 32 over 5 minus 0. Because if you put in 0, it's going to be 0. So on expansion, I have 216 plus 64 minus 230.4. So I have 49.6 pi. So that is the way to go about it. So you can see it's very simple. Just take the necessary steps and you arrive at your answer. The part of the curve y equals x cubed from x equals 0 to x equals 2 is rotated completely round the y-axis. Find the volume of the solid generated. That is 1. 2. Find the volume generated when the area generated between the curve and the x-axis is rotated about the y-axis. Add the answers in 1 and 2 and show that it is equal to pi x square y as a solid cylinder. So let's start. The first one shows that, let's say it is a curve like this, and they are asking us the volume generated when this part is rotated about the y-axis, and we have said that is going to be pi x squared dy from x1 to x2, and we see that our y is equal to x cubed. So what is y equals x cubed? So from y, this is from y1 to y2. Sorry, this is from y1 to y2. So we are going to have x equals to y raised to power 1 over 3. So x squared is equal to y raised to power 2 over 3. So we now do the integration from within the two limits. So v1 is equal to pi y raised to power 2 over 3 from 0 to 2 dy. Oh, sorry. So I wanted to find something. Y is equal to 0 when x is equal to 0. Y will be equal to cube root 2. No. Y is equal to 8 when x is equal to 2. So now let's start. So our range now will be from 0 to 8. So we are going to have this. So v is going to be pi y raised to power 5 over 3 over 5 over 3 from 8 to 0. So the volume generated is now going to be 3 times 8 raised to power 5 over 3. Because if I put in 0 here, it's going to give me 0. So it's going to be 3 over 5 times 2 raised to power 5. And that is 3 times 96 over 5 pi. 96 over 5 pi. So the answer to the first one is 96 over 5 pi. Now let's look at the second one. The second one is this. It's something like this. And this shape is now rotated. So the volume generated by this that is what we are looking for now. The volume generated by this one, that's what we are looking for. And we got the volume the other time to be equal to 2 pi x y dx from x equals to 0 to x equals to 2. That is the range. So let's continue with this. We know our y to be x raised to power 3. So it's going to be 2 pi from 2 to 0 into x times x raised to power 3. Yes. And that is 2 pi 2 to 0 x raised to power 4. Yes. Which is 2 pi for x raised to power 5 over 5 from 0 to 2. And what is x raised to power 5? That is 32 times 2, 64. So we are going to have it as 64 over 5 pi. So the answer to number 2 is equal to 64 over 5 pi. Now in the third part, we are asked to add 1 and 2. So this is the third part. So that is 96 over 5 plus 64 over 5 pi. And that is going to be 160 over 5 pi. What does that give? 32 pi. It's not asking us to show that it is equal to pi x squared y as a solid cylinder. So what is our x in this instance? So x is equal to 2. When x equals to 2, y is equal to 8. So it is going to be something like this. When you add the whole thing, it's going to be something like this. So from here to here, it will be 2. From here to here, it will be 8. So pi why we have it like a leaf that moved round for the remaining parts. What I mean is this. Look at this one. So it's just like you scoop this place out, and then you now rotated this. That is the second part. The first part is this one. Sorry, I think it's from the origin like this. So the first part is this one. The second part is this part. So now, when it is now a cylinder, it means that we scoop this part out, leaving this place. So the second part is the remaining part after this one is scooped. So you can see how accurate our results are. Thank you very much. See you for more on this. I will surely post more. Thank you very much. Kindly subscribe, share, comment, follow. Please, if you have not, kindly tell others that can gain from this. I believe that what we have there, so many people can gain from it. Follow, yeah, you can in our other channels. Thank you for the support so far. I appreciate you all. See you in the next video.